A quick discussion of eccentricity. Here are three ellipses. The first ellipse is drawn within a square, and that's going to be a circle. Second ellipse is drawn within a rectangle where the squares become slightly elongated, and so we have an elongated ellipse within that rectangle. And now we've really elongated the rectangle here, and we have a very eccentric ellipse. Okay, it's much longer than it is wide. Okay, well, what about the location of the focus? Remember that the focus is at square root of a squared minus b squared, and if we assume that a is this dimension, okay, we don't even have to worry about the absolute value sign, but that's not difficult to deal with. Okay, so let's see. For a circle, the a quantity is equal to the b quantity. So a squared minus b squared is 0. So the focus is the center. Okay, and in this case then c equals 0. Focus is at the center. And you can see geometrically that the focus is at the center. Anyway, if you think about what the foci tell you. It's kind of trivially true for the circle. Okay, well, we elongate a little bit, and now a is a little bigger than c, so the square root of a squared minus b squared is not going to be 0 anymore. b is not 0, so c is going to definitely be less than a. Well, in this case, maybe c is less than 1/2 a. I don't know if it really is for the dimension of that rectangle. I wasn't that careful. But you can see that if we slightly elongate the rectangle, then b gets to be at least some small number. So when we do b squared minus a squared, or a squared minus b squared, and I say b is going to be a small number. B is going to be a little bit less than a, so that a squared minus b squared is going to be a little less than a squared, and the square root of a squared minus b squared will be a little bit less than a, or at least maybe a little bit more less than a. So in this case anyhow, c, the focus, would be like here. Okay? Maybe it'd be a little further this way. I'm saying that here it looks like c is less than half of a, and that's really kind of a key. Okay? Remember, a is this distance, c is this distance. So mainly what we're depicting here is c being less than 1/2 of a. Okay? Now if we make a really elongated ellipse, the foci move out here close to the edge, or to the end of the rectangle, close to the vertices. Okay, so now c is getting pretty close to a. Okay, so c is close to a. Here c is probably less than half a. Here c is equal to 0. Okay? Well, if we define the eccentricity just to be c as a proportion of a, in other words, the ratio c over a, c over a is 0 here. With this elongated ellipse, c over a is getting pretty close to 1. It's still less than 1. For an ellipse, c can't be less than a because the square root of a squared minus b squared is less than the square root of a squared, which is a. Okay? So c has to be less than a. And here maybe c over a maybe 0.3 or so. Okay? This distance divided by this distance. Okay, so you just see the distance c wherever the foci happen to be. Take this distance as a proportion of this distance. If this is 3/10 of this distance, then c over a would be 0.3. If this distance, let's say here, is 80% of this distance, then c over a would be 0.8. So there's your eccentricity. Of course, you got to know what c is, that it's the square root of absolute value of a squared minus b squared, and you divide by a only if a is the major axis. If b was the major axis, you'd be dividing by b. It's the distance to the foci divided by the length of the semi-major axis. Or if you want, it could be the distance between the foci and the major axis. You can think about that.